Welcome everyone to the SMP community meeting. Today is 19th of August, and we have a long list of topics to discuss today. Otto will not be able to join us today, but hopefully you'll be able to join in the next week and discuss about adaptive load controllers. So a couple of announcements before we start the meeting. So SMP has a new community group in CNCF community groups. So you can join this community group to get updates on events running around SMP and all the details of past and future events. So the link is in the chat, so you can join in right now. Moving on to the first topic of the day, Lee, would you like to talk about the recent IEEE publication?
Yeah, sure. Actually, this is hey everybody, it's nice to see you all. As a matter of fact, just a quick congrats to Tom on an incubating project. So
thank you very much.
Yeah, it's no small feat.
No, thank you.
Very good. So while I expect that I'll offer up my voice on a number of the bullet points here, this is one that maybe I can shut my yapper on, and Sunku might be able to tell us a bit about the first topic. I'll put him on the spot.
I was just about to say that I just woke up and I'm like, okay, I'm talking now. Okay. I'm trying to frame my mind. Yeah, regarding the article. But by the way, thanks, Lee, for putting this together and working with the team to, I guess, the IEEE Bridge team to put this article, publish this article. So the abstract and the article I think the original thoughts were something else, but given the time and the deadline, we kind of finalized on going with the current set of research and data that we have. So the outline, we primarily went with, why is performance measurements for a service mesh important? How do you look at measuring something? And then we dug into, what is measurements about? How do you measure something? And so what are some of the things from a hardware perspective that you need to keep in mind? And then from a benchmarking perspective, what are the traffic generator items that you need to consider? Like that's which is what the Otto has written about, right? So how do you configure a traffic generator? What are the things you need to keep in mind from a load generator perspective? And then next part is about specification, which is great that we did touch upon what does the SMP spec covers about, or why is it important? And then it's about automation, which is where Measure comes in, talks about like how can you ensure this is repeatable, have a consistent set of results. I guess that's the brief outline of the paper. I believe it is open for anyone else if you want to comment or look into or add in. But I guess the deadline is something we need to look into to see how soon we need to send this out. But not sure if everyone else had got the chance to take a look. But I think overall, with the diagrams and what the content is today, it's a good, pretty good state. We could share it with everybody else.
Nice. Good. For those, just a quick test then, for those who are in the meeting minutes, are you able to access this draft, this doc? If not, we'll get that changed. Okay, good. And by the way, just on the topic of logistics, there is, well, now sorry, I think I pasted the wrong clipboard, but there's another, actually click, if you go to that link, what is that one? Okay. So if you go to this link, if it isn't available to everyone, I'm going to double check, make sure. If it isn't available to you, then please do this if you would. There is a shared folder for the service mesh performance community for this project. There's a shared folder in the Layer 5 community drive. The link to that shared folder is in the Zoom chat. So feel free to request access there, or maybe if you'd like to get access to the Layer 5 community drive that has Meshery, Get Nighthawk, SMP, SMI conformance, the GitHub actions, the logos, the site content, the 5 project sites that we have, like just sort of all of that. There's a couple of things that you could do. Probably the best thing to do. I apologize for a little bit of housekeeping here. But since the project is relatively new, we don't talk about it. It's really good to talk about this. There's Layer 5, just it really focuses on community. And so there's a lot of process around trying to run community very well. There's a little over 300 people who've contributed to the projects that are here. There is a new community member form that is just got a few questions, but probably the point of filling in the form for some of you is that it will grant access to the community drive overall, which has quite a bit in there about the way that things work and what's going on with some of the things that we'll end up talking about in this call about Get Nighthawk, distributed performance analysis, a number of things. So I encourage you to fill in the form, and you should be granted access pretty promptly to all of these. So back on track of what Sunku was saying, there's a second. So this draft that's out there, please review. Point out all the spelling mistakes, point out things that are not interesting, or where, if you feel like the meat of what was presented maybe isn't juicy enough or isn't thick enough. Like comments are welcome. Please jump in. The article itself, Sunku has ensured that it does a few things. I mean, it sort of introduces service mesh performance to the reader, as well as talks a bit about the notion that Meshery has implemented it. But it also talks about the need for such a spec, the need for at least the spec in its current state. And Tom is actually here. We've been talking about the charter of the project itself, and so we'll talk about charter hopefully in a little bit. The original, okay, and so this is good. So at least so Sunku, I don't know that I got a chance to tell you this or the rest of the community that as you wrapped this up on Monday, it was just shortly thereafter it was sent to the IEEE for review, and they had said that that a second article sometime in the future is sort of pre-solicited. so that other doc that has the other abstract, the abstract that's a little more, intriguing, I think, in terms of what's the title of it, Techniques of Adaptive Service Mesh Optimization, is where we're hoping we'll leverage some automation, some intelligence in Nighthawk, some automation through Meshery, and some things that we'd like to research, I think, in this project. And that there's a forum to potentially publish those results again. Although I think, Sunku, by the time we get there, you might have other ideas about forums for publication, depending upon maybe how you just with your familiarity of the IEEE, you might have suggestions on how well.
Yeah, no, absolutely. Yeah, no, definitely. I think that's great that they're open for a second article as a continuation. I guess this one introduces the what performance measurement or how do you measure or characterize a service mesh, and then kind of builds on to like the adaptive part of the whole SMP. Yeah, I mean, from IEEE side point, there is a performance measurement group for NFV, like basis for 5G niche compute. That's an area that we could share this with. And also there's IEEE Computer Society. There are a couple of chapters, or how do you call it, as a couple of sections that are working on service mesh side of things. So that's another area we could reach out and kind of build on this one. Not just performance, but overall, even the meshery is a complex enough piece that it can go by itself. So I'll find the right link and definitely connect with them and with this group so we can share more details.
That'd be great. That's wonderful. Yeah. Okay. Well, fair enough. So good. So already the project is producing.
Absolutely.
I think so. Actually, it sounds like next up, Nivendu, are we to Tom's discussion?
Yep. If you could just start us off.
Yeah, sure. So for those of you who've been around, so most of the names on the call are familiar, by the way. It's a community tradition to, well, break the ice with folks who are new on the call. And so, Srinivasa, have we gotten a chance to say hi before? Have you got a chance?
Yeah, hi, Srinivas here.
Good. Nice to meet you. Very good. Say a bit about yourself, if you would. Your favorite color.
I'm from India, so I'm working as a technical lead. So totally having around 13 years of developer experience. I'm in microservices, cloud, AWS, and Java related technologies. Yeah, this is about myself. Yeah.
Awesome. You're in the right place. Good. Very nice to have you.
Thank you.
Oh, good deal. Okay. So as service mesh performance, as this project was prepping to go into the CNCF, there was a discussion about all of what it's covering and its focus, its charter. And part of that discussion was with Tom. Tom is a maintainer of CADA. And if you're not familiar with CADA, well, Tom, do you want to give people a quick introduction to CADA?
Yeah, sure. Nice to meet you, everybody. So I'm indeed Tom Kerkhoven. I'm one of the maintainers of CADA, and CADA's sole purpose is to make application auto-scaling that simple. Today we support around 35 systems on which you can scale. And HTTP is a very big story that we're working on now, which is a bit harder. But the issue we have there is you have ingress and gateway API, you have service to service, you have service meshes, but there is no unified way to get metrics around the traffic there. So SMI has a nice specification for this, but it is purely focused on service meshes. And I'm looking for a way to open up that specification so that it is applied for any traffic type, basically. That would allow us as an external system to get the metrics without relying on something like Prometheus, because some customers don't use Prometheus, but their cloud provider instead, for example. That's the main idea.
And so,
Go ahead.
No, go ahead. That's great.
No, I was just about to ask, and it's good that say looking into having a comprehensive way to get the metrics. So now, how is I mean, I'm not familiar with CADA. I could see the full form of it is event-driven architecture, or
Kubernetes event-driven auto-scaling.
Auto-scaling, got it. So how is it related to service mesh, or is it independent that you're just looking for a way of unifying the both?
It's fully independent. So you can deploy CADA in your cluster, and then it is up to you to say, okay, I want to scale this application here. It could be based on a queue, which is a typical example. But if you have a service mesh, you would want to scale based on your traffic. that you have towards your service. So SMI would help there, but we want to have one specification regardless of your traffic type, be it north to south, west, east-west traffic. We want to support all of them with just one specification, preferably. And here you can see all the scalars we have today.
Wow, that's great. So what kind of events do you consider as important events?
Well, in HTTP, it's not really an event other than we have, let's say, 3,000 requests per second. With the current workload, we cannot handle that, so we'll need to scale out, basically.
Okay, got it.
So yeah, we could implement it depending on the traffic type and all the systems, but that's a bit of that's a lot of work. And SMI does what we need, but it's just focused on the service meshes, and we were hoping to get that in a broader scope.
Yeah, this kind of reminds me of telemetry aware scheduler. I know it's independent of like overall set of events that you can define, but I mean, in generally, I think the Kubernetes extension, like it's based on custom metrics API, and that would scale your cluster using horizontal pod autoscaler based on some of the telemetry events that you define, or thresholds or triggers that you can define based on telemetry. But I guess the events here can be anything that you define as an event, not just a set of metrics.
Yeah, and you can also build your own scaler outside of Kata that also triggers the scaling. But we extend the HPA. It's not that we reinvent the wheel. So what you said is actually what we do. We serve the metrics to Kubernetes so that it can feed the HPA with the metrics and trigger the scaling, but we also do scale to 0 and from 0.
Yeah. So yeah, performance metrics for something like this then would be not just latency, percentile latencies, but you want to look at across the cluster and define what's the source and destination, and identify based on that, right? So, because I mean, from a Kata perspective, it is scaling or changing a cluster based on your customized set of metrics. From a performance standpoint, are you looking at establishing how well Kata does, or is it more about once the scaling has been established, then you're looking at parameters for what's going on afterwards?
No. So we really want to scale based on your traffic. If your traffic suddenly grows with 300%, we want to scale your application so that they don't suffer. That's what we want to focus on.
Right. I mean, I guess the question is with respect to the establishing performance side of part. I mean, if you're looking at SMI or SMB, it's these metrics. For example, SMI, some of the metrics they define are how do you measure P99 or P90, these type of latencies. From a Kata standpoint, what do you want to measure, I guess is the question.
All we want to measure is the amount of requests that my application receives. So that based on that, we can benchmark, okay, we can handle 300 requests, for instance, for example. So that means if we go to 1,200 per second, we need to compensate for that.
Yeah, I'm just trying to figure out how everything fits into the spec. Yeah, but yeah, so go ahead.
Yeah, no, this is good. As well as, or yeah, it's an exploratory conversation, and I'm trying to figure that out myself because I desire for the answer to be yes. I don't. So some aspects of what Tom had described in the past are, well, Tom, let me assert something, and you tell me if this is a lot off or if this is too myopic. But so of the scalars that CADA has today, there is not, or are you in search of, or is it a roadmap for a generic HTTP scalar? Is that part of the, okay.
So it's not in our core, but it's an add-on where CADA core doesn't intercept anything. It just checks what's the queue depth. Okay, based on that metric, we scale that application. HTTP, however, is more tricky because it's synchronous communication. So you need to intercept, because if you scale down to 0 or from 0 to 1, you need to halt the request, spin it up, and then forward it. That's why it's an add-on where we have the interceptor. This is purely for ingress, by the way, but the concept would be the same, where the interceptor keeps the requests, and then based on a metric source, we decide for the application itself if we need to scale it. So in theory, we have an interceptor, we could measure everything ourselves, but we want to really rely on the technology that's already there, such as SMI.
And part of
it's not on the documentation. I'll actually paste the link.
in an ideal world, the HTTP scalar would generically be applicable to, well, in some reason, well, would be generically applicable. Maybe that's the statement.
Yeah.
Like, and that sort of.
Totally agree. Service to service, service mesh, ingress. It should all be generic.
So you mentioned like the API gateway and Kubernetes before, like the ingresses that are there. Good.
And SMI has the spec to get the metric, the traffic metrics. I think they're thorough enough. But we just have to find a way where it opens up to not only be service mesh specific.
Yeah, I guess the metrics described by SMI is, we had this conversation in the SMI community. So they do consider east-west traffic where you could determine like one application source, one is destination, and of course you have service mesh underneath. But then the issue with that is, so good that you're defining two applications and two endpoints, and then you're measuring so what's your transactions per second or HTTP rate, and then your latencies between those two. The specification, however, I guess in my opinion, the way the place where it limits itself is it doesn't consider anything underneath, like neither the infrastructure from a hardware standpoint or the environment it runs in, nor does it consider so what other set of Kubernetes components which might add to the performance impact, right?
But the question is, should I care as an end user of those metrics?
I would say yes, because so if you already decided on your environment, right? So okay, I need so many gateways or so many hops between these two endpoints. All I need is my performance, sure. But then if you're looking to optimize your latencies or your throughput, then all of these number of hops in between and the infrastructure underneath plays a very important role, right? And that's where.
Okay, but yeah, I think they are related, but they're you can see them separate as well. I mean, if I do a benchmark today, my technology does not change. I'm purely interested in the requests per second, no longer the infrastructure underneath, because we already did the benchmark, so we know what we can handle.
Sure.
So from that perspective, it's enough for us, let's say.
Yeah, I mean, identifying the components in your deployment is like you said, it's already identified. But in terms of tuning, in terms of configuring these parameters, each of them, in order to have the best and optimal kind of environment, optimal performance, and in terms of specification, identifying these, laying them down in order to fine tune for your environment, I guess that's the important part. I mean, from load generator standpoint, it looks at, okay, what's my source, what's my destination, and here's my result. But from a specification and actual test perspective, we need to kind of consider these and make sure they're either optimized or unnecessary hops can be removed, or traffic patterns could be identified. That way you don't necessarily have to go through certain hops, right? So I guess that's where the overall specification comes into play.
Yeah, and so I think that both truths can be held in at the same time, or that, yeah, if Tom, your phrasing of from an end user's perspective, if like, and I'm gonna put some words in your mouth, but clarify this, if this is like from an end user's perspective, if the primary question in their mind and sort of the goal that they're focused on is guaranteeing a certain response time, or guaranteeing a certain or like, it's like if the focus is on making sure that infrastructure is scaled appropriately, not wasting money, but also not providing a poor experience to end users, then and there's a number of concerns within there, and just dealing with that one question of like, hey, how do we elastically respond to like intelligently, such that we're maintaining a requirement from the end user that says, I'd like to receive a response within this time frame, or like, and I don't want it to cost me $1 million or something. I think that's that captures the essence of, and then part of Kata's challenge is like, okay, great. So, but also, those HTTP, those requests, like you were saying, might need to be, if you're going to intelligently, you might need to grab those, hold on to them for a minute, scale some things, and then pass them along. And then B, you might need to, those HTTP requests could be ingressing through a number of different types of infrastructure. And so the mechanics by which you analyze those and determine whether or not they're achieving the right latency, the right quartile, it differs. And that's in part, I think, what you're trying to solve. If you were to expand the question or look at it from the perspective of, one of the perspectives of what Sunku was saying is around, well, like, hey, if you peel open, if you go down a few more layers, and then you say, are we even using the right infrastructure? Is there an optimal configuration that could be used that helps eliminate the need for scaling as much, or for getting more out of the infra that's being used, or hey, for that style of workload, or that signature of requests, could a different type of different type of infrastructure be used? Could the service mesh be tuned? Could the infrastructure be tuned? And so if you're taking the question that far, then maybe those secondary and tertiary layers matter. Mm-hmm. I'm not saying that they need to matter to Kata. I'm just saying, like, hey, it depends on.
I agree.
And so hence, as SMP was discussing with SMI, how to best align, it was what Sunku was just articulating was like part of the issue with SMI not being myopic in its focus. And so that hence part of the charter discussions, like when Tom was jumping in at the right moment, asking this question about, is part of what the value that SMP could potentially provide. Well, is a system a way of characterizing HTTP centric traffic and its performance generically, irrespective of where it's coming from, what infrastructure it's transiting. Which I think, like, if it's done generically, like it's also the case that it's it could be physical hardware, and therein part of thinking about that makes the hair on the back of my neck stand up, because it is a decent sized scope. Or like if you went off to just solve just that problem, but do it holistically. Yeah, there's a lot of, and if you want to do it holistically, but also achieve in part what Sunku was describing about, well, hey, if you've captured the right amount of infrastructure centric data and configuration information, then you could go over and do tuning and do analysis and say, hey, the traffic itself is being routed over 4 more hops than it should be, or you shouldn't be using that architecture chip, or whatever and like actually capturing all that is like, to take a deep breath, because there's a lot behind that.
Yeah, I agree. And that's where I think trying to consolidate all of those into a simple spec or simple deployment, that's a tricky part. I think Mesh-Ray has, set patterns and rights of how you deploy your environment for performance measurement, right? So you get really define a lot of these components. I mean, of course, like from a Mesh-Ray standpoint, it's independent of the hardware, but at least from a mesh deployment standpoint, for example, you could really figure out, so what are the components I'm deploying, because that would be a controlled test environment. And then, so how am I, what are the resources, like you're showing here. So what are the amount of resources I'm providing for each of these components? And that way, I'm suddenly not using one of the components, suddenly don't start using a ton of RAM, and suddenly performance latencies are, all over the place. And then once you have this controlled deployment, then you can start looking at, okay, east-west, like what's my throughput and latency. The importance of these is that the latencies, at least from what I've noticed, they're very, very sensitive to what's going on across, to Otto's point, generally, like we described, so depending on the load generator, your P99 latency can vary 10%, 20%, 30% sometimes. And that doesn't make any sense. Like, you're not really, it's not really representative of anything, although you just run the test and you get some numbers. And that is where this type of controlled environment is necessary in order so that you get some repeatable results.
Right. Tom, for you, as you, and I think Tom, you've been in our conversations. I think we've both been thinking aloud, kind of in a brainstorming mode. One of the here's a question for you. Can you characterize your ideal, or if SMP could do the ideal thing that you might like for it to do?
Provide a specification that allows us to get traffic metrics. I think SMI now gives it in percentiles, or yeah, we just need one number basically. Probably people will want to have the 95th percentile or the 99th or whatever. That's fine for us as well. But the most important point for us is decouple from service meshes, and I'm not sure if yeah, that might be a problem for this group. because SMP is service mesh performance. So,
Right. Yeah. I certainly think it's within scope for SMP to like right now the proto, like this one in particular, there's like 3 of them, but it needs to go deeper, and that there's an open call for adding a number of other things. One of those being, well, not just the service mesh ingress, but your Kubernetes ingress or your Kubernetes ingresses for accounting for the API gateway that's being defined. Those things are near at hand and relatively, straightforward to account for. When we start to go and like, yeah, I guess when we start to go look at VMs and their interfaces or hardware and their interfaces, like tagging the traffic or basically it's still the same result. I think from Kata's perspective, like still would be looking for a single number to key off of. Whether or not SMP, when we open up that conversation and talk about all the interfaces that SMP should be concerned with, maybe it should be concerned with VM interfaces and hardware-based interfaces, or maybe not. And maybe that actually doesn't really matter to what would help to what you're looking to get to, because actually
for us that's less important indeed, because we come from a developer perspective, and we just care about the requests per second, typically.
Yeah, it's still a bit up in the air with SMI. Like part of what SMI and SMP both are still working toward is figuring out which of them has more of an appetite to, in some respects, like figuring out which of them has more of an appetite to move more briskly, to really address concerns beyond just east-west traffic. About half of the maintainers that chimed in that are on SMI had said like, oh, maybe SMI's traffic metrics should go to SMP. About half the folks between the two said maybe the two projects should come together. Like those are still open discussions. Part of getting SMP into the sandbox was to facilitate figuring those things out. Of what you've seen of, so to recharacterize this a little bit, you said this a moment ago, so I apologize, but of what SMI has for traffic metrics currently, the pain point that you have with it now is its myopic focus on service mesh only. We lost.
No, I guess yeah, the way to look at this is like peeling the onion, right? So like Tom said, first is from an application writer perspective, what are the basic metrics? Requests per second, latencies, great. So you can have that independent of your infrastructure, like you have everything deployed. I just need some numbers, great, you can have it. And then you dig deeper and understand the hops, understand your configuration, then you can dig into the resources for each of these, like hardware or software resources, and then dig deeper, how is my infrastructure impacting, whether it's virtual machines or hardware, bare metal, whatnot, right? So you can look at it from multiple layers perspective, and depending on the depth, you can go there. But I guess the SMB standpoint, at least the specification looking to address almost across these 3 levels, and based on whoever wants what, like they can pick and choose.
Yeah, that resonates with me, Sunku, the way that's described. And I think it achieves or helps achieve in part what Tom is looking for, both what he's looking for and also what he doesn't care about, or not in a bad way, but Like, and it's kind of, you know, what you'd said is like, hey, if the spec goes on ad nauseum, having placeholders for capturing the finest level of detail about the driver version number on the NIC for your AKI, or like, you know, like some, you know, some super, you know, all the way from that, all the way up to distilling it all the way up to just like, you know, like here's your sole indicator, like here's like the one number. Yeah, whether or not a given implementer of the spec, how deeply they go and how much configuration data and metric data they collect about all of the systems that affect that high level number. You don't like, they don't, that those details don't have to be there. Like you basically starting top down. So like that you have to have this number or these set of numbers, and then your mileage varies, you know, depending upon how, you know, how far down you want to go. That type of an approach makes sense to me. It's in part what Meshry does today. So Meshry doesn't, when you run a performance test, it will first and foremost focus on getting you these statistics and along with a couple of other things, but not in all cases does it get all of the other metrics that you see described. It's still working toward that. And so actually today's sort of implementation in that regard marries up with what you just said, Sunku, about layers of details. Tom, what's missing again from the SMI? Not that they're from the SMI traffic metrics. It was it the myopic focus on east-west services?
Yeah.
Okay. Yeah. Right. So yeah, if you actually try to use it, it's like, well, it's like, hey, great. These numbers are great. These are very helpful. We can scale off of these. But what do they represent? Oh, you know, this slice of like, yeah.
Yeah. If we implement SMI, we only have a subset of the customer base, and it's a bit weird asking an ingress provider to implement SMI just for this.
Okay. Actually, so yeah, I think I'm getting a much better picture, which is to say, like, yes, or like, yeah. I mean, it's a great, like, to give a real example is something like, to use Meshry as an example as it implements SMP. You can take Meshry and deploy, you know, this about the one that I'm running on my desktop. It's running three different types of service meshes, and you can run workloads on them, and you can do performance analysis of those workloads in context of the service mesh. And great, and it's all in the mesh and mesh specific. Or you can turn down your Kubernetes cluster, have Meshry sitting there, and point it at, you know, google.com, or point it at your payment gateway that's running on, who knows what. Is it still going to produce a set of performance results that have minimally this plus some additional data about the endpoint that you were, additional data about like how long you were running the test, at what intensity, at how many concurrent threads, what type of load were you generating? Like, yeah, it has all that. So it has all that today, irrespective of whether you're testing something on the mesh or off, because that's actually one of the core use cases for what people, like part of the genesis of the project was people saying, well, we're running a workload today and we know what that overhead looks like, or we know what that, we can characterize its performance. Now, as we go to put that onto the mesh and it does stuff for us, great, we're looking for that, but what's it going to cost us? And so like one of the first questions people ask is like, what's that? How do you compare? What's the difference in performance between being on the mesh and off the mesh? It's like, yeah, with that. So Meshry is not reliant on a service mesh. It's not reliant on Kubernetes being available either. If you don't have Kubernetes available, or you don't deploy a service mesh, there are other aspects of what Meshry does that you know, those dashboards won't be filled in, or you know, that functionality doesn't work. But the core, but what I just said about the characterizing the performance of a given endpoint or a set of endpoints, it holds true irrespective of whether a mesh is present or not. So I don't know that that means like, oh, okay, the answer to what Tom is asking is yes, and there's nothing to do. Like it's just there. I don't like there's more work to be. All right, I think
I think if you just carve the traffic metric spec out and just call it traffic metric spec, well, to put it very bluntly, but if you put it that way, and then yeah, the tricky part is just driving adoption. But it's a clear sign that this is purely about traffic and metrics, regardless of the type of communication.
Okay. Yeah. No, I see what you're saying. And so to make it helpful, to make it helpful to CADA, if those that is it both?
Imagine you're an observability provider, and there is one spec for all traffic types. I think there can also be nice tools and products building on top of this.
Yeah. Yeah. It's a great. Yeah. Having led technology strategy at SolarWinds for a little while, like, hey, it's easy for me to put myself in those shoes, or in my old shoes, and yeah, I mean, there's a ton of value there. I mean, like I had proposed it while I was there. I don't know. There are certain forces in the industry that like would potentially not like that, because part of the value offering that they have is doing things that are infrastructure specific, or doing things, but in some respects, like the 4 golden signals, if you will, is sort of related to what we're talking about here, which is like, hey, irrespective of all of those underpinnings, like to your earlier question, if your focus is on the end result, it's like none of those underpinnings actually matter at all. Even if you had a single CPU VM that was what is it, an AWS, a tiny or a teeny or something, that a micro, and you're sending hundreds of millions of requests per second to it, like, yeah, it's totally the wrong infrastructure for this. It couldn't even possibly handle any of that. But in some respects, like that doesn't matter. What matters is, yeah, the response time on that is like 10 hours to get a request back. That ultimately that end signal mattered. So yeah, for observability providers and for consumers, those operating infrastructure, there's a ton of value in just being able to say, it's in part what we were looking to achieve. Maybe, I don't know if I've described this before. It's probably, in part, one of the things we're looking to achieve with the project itself is, well, and again, it has the word mesh in it, but is to provide people with a single number, a universal performance index to gauge, like if you were to insert, instead of like, your application's efficiency, or your, like, basically in some respects, the initial thought is like, how well is your, for a given workload running on service mesh, can you succinctly articulate and refine it down to a single number? Like, how are you performing? The concept here is that it is intending to take into account some of those lower level considerations, because if you were running a T2 micro and it was handling 100 gigabillion requests per second, versus you're running, a massive cluster of very expensive machines and they're handling 5 requests a second, it's like, well, you actually have a lower score because it was a measurement of efficiency. Like, your infrastructure is not, you're being inefficient. You're way over provisioned. And so, yeah, I mean, that's so that we've yet to start in earnest on defining the algorithm here, or how efficiency is calculated. It's possible that this might account for a financial aspect of your, of that infrastructure. I don't know if this hits closer to the mark, pun intended. But like if you're looking for one number, that number in this case, you wouldn't be interested in the financial aspect of it. Yeah, I do get, I think I can re-articulate the need that you have, or like the thing that you're looking for. Just trying to align it to. So one thing is like, hey, even though this project is called Service Mesh Performance, it doesn't mean that there isn't, that there can't be a section of the specification that's explicitly called something generic that is the golden traffic metric or whatever the thing is, that that we try to rally others around and try to have blessed as like the canonical unit of measure for HTTP requests. Like in this case too, as we go to focus on gRPC and potentially on NATs. So from Kata's perspective, you guys measure NATs in a certain way already, I think. And then what about gRPC?
We don't support that today yet.
But that sounds like that might, if there's.
But that would be the same problem indeed.
With respect to like, if it's constrained to service mesh, you mean? Yeah.
We would need to measure it somehow as well to know when we should scale.
So as we look to support, do performance characterize performance in context of gRPC traffic, the same approach is to be taken where if this performance can be analyzed outside of a mesh or in context of mesh. If it's done in context of a mesh, there might be a higher fidelity, there'll be a higher set of details to dig into behind that, because we'll also examine what the proxy is doing and tell you about its queues on there, so something.
Mm-hmm.
But that doesn't mean that if the mesh isn't present, that you still wouldn't achieve that higher level number. You just you just couldn't ask it more questions or as many questions rather.
Yep, agreed.
Yes.
But again, from an adoption perspective, if it has service mesh in the name, I think you'll block yourself. Yeah.
So,
well, you could apply it to anything, like you say.
And it becomes more valuable to I mean, like part of the value proposition that the thing that Tom is walking us through is not pigeonholing the effort, is like potentially pigeonholing this particular effort on just service mesh and sort of constraining its potential value to only those that are interested in that infrastructure, but saying there's something more here. And so Sunku, I guess, I suppose things to reflect on as the things to simmer on.
Yeah, no, absolutely. I was just about to say, I think, it's one thing I was about to ask Tom, but probably could help define what this would look like, what from an application developer standpoint, right? So what exactly you need. So I guess the way to look at this is once we have something like this defined, probably implemented, we could make it generic, just the specific part, because I mean, this is applicable to any set of microservices, so to say, Kubernetes or not, right? This is performance between two microservices. And I mean, the way we are automating things or configuring these is within Kubernetes environment, within service mesh environment. But this is ideally applicable to any microservice benchmarking type scenario. So maybe you could look at to see how we can make this generic, either the the tools around it or the specification around it, right? Deployment around it. So generic enough that anyone can come in and say, okay, let me pick that up and kind of configure it, follow this set of recommendations, configure it in my environment. And of course, we can dig deep into service mesh part of it, which can be separate. But if you have something generic enough that in terms of performance, anybody can pick it up and use their test suite.
I'm not sure I get your question. Are you asking how you would consume it, or what
Right,
exactly
so,
that we need?
Yeah, a mix of both. In terms of defining, what is generic enough that you could leverage. And I understand the name service mesh performance kind of can throw off someone else like that. They don't care about service mesh, but they care about the performance, microservice performance. So like if you were to create something generic enough, similar to what you saw with SMI and figured that, oh, hey, this would be helpful from a performance standpoint, right? So if you create something generic enough with a generic name, probably you could provide some of the requirements as to what is it that you're looking for would be good enough that you can say that it's generic enough, and then we can look at how we can build that or
Well, I can already give you an answer. I don't have much of criteria other than just have the traffic metric indication. And I saw the profile earlier where it had 99, 90, 50 percentile, an average, and success and failure rates. I think for us, that's enough. And ideally, there would be a Go client or something similar to how SMI leverages this. And I think that's a good start. And then it can grow if there's a need, but
yeah, perfect. Yeah. Yeah, I think we can look to see how we can. Yeah.
No, go ahead.
I was about to say, like, we can start off with this and see how this can be a very simple layer to start with, and then see how we can make it generic enough.
Nice. Yeah. This is good. Yeah, I think the only the meat of what Tom is after is well aligned and actually is a natural, there's no or from my perspective, I don't think there's no tectonic shift here. There's no like, oh, that the ask like breaks a design principle or something of the project. Like it in many respects it doesn't, or I'm sorry, in all respects it doesn't, and in many respects it aligns with what's already happening, which is, hey, if there's a certain level of details that you're interested in, great. You need to be running that infrastructure to be able to get those details, and if you're not interested in it, then as long as like that, I think from Tom's perspective, as long as that principle is upheld, that a service mesh isn't required, and that these statistics are universally applicable, somewhat irrespective of entirely irrespective of what, whether, even if you're running anything virtualized, potentially it's just, now whether or not the Go client would like facilitate getting physical network metrics is like, well, that's not what Tom's after anyway, and so he doesn't really care. But I mean, technically the metrics apply to physical stuff, but the one stickler, and I totally get it, is service mesh in the title, like either of this or in the title of the spec itself, or of the of the way that it's couched and cast to everyone. I think
that will influence the adoption tremendously. But I get why that is not an easy thing, but maybe there could be a generic one with a service mesh edition, let's say.
Yeah. Nice, good. Tom, thanks for this. I mean, I know
My
it
pleasure.
takes a couple of times for me to get it, at least for me.
No
Simco
problem.
seemed to get it right away, though. I don't know what's going on.
It's one thing to ask for things, but helping is another way to make it happen. So if I can help more, just let me know. Thank you.
On that, I guess, Navendi, did we have any egregious, any super urgent items as we hit the top of the hour?
I don't think so. So Otto will probably join the next meeting and talk about adaptive load controllers. And Rudraksh is, I think, working on distributed performance testing with Nighthawk and on the Get Nighthawk project. I don't think there are any other urgent items to discuss. So we'll see in the next, I mean, in 2 weeks, in the next meeting. So thank you everyone for joining.
Thank you,
Bye-bye.
Navendi. Thanks, Simco.
Thank you, everyone.